right, hello everyone. Welcome to the second afternoon session of the data visualization and image processing track. I want to welcome Trevor, who's going to talk about anywidget now, and let's give him a warm welcome.
Thanks everyone for joining. First I want to apologize for the number of times I'll be saying widget today. It'll be, and the original title of this talk was Authoring and Sharing Reusable Interactive Widgets in anywidget. And after following Julia's talk yesterday at the keynote, I thought maybe a more appropriate title was the gateway to just enough JavaScript. And I hope that this is sort of tongue-in-cheek, and I don't want to scare anyone out of the room, but I hope the story today that you get out of this is that by embracing what the web ecosystem is great at and what the Python data science ecosystem is great at, and really embracing the platform, you can build really exciting user experiences within computational environments. So I'm Trevor. I'm a visualization researcher at Harvard Medical School. I'm finishing up my PhD in the High Dive Lab, and I love open source software. I work on web-based visualization tools, but also I really dig down on the Python side to work on representations and taking advantage of all the standardization and all the great work for actual data processing and getting data into these tools. So like I said, I build interactive visualization tools. And as a part of my work, I'd say the focus over the years has been to try to bring these tools that I know exist in the visualization community and put them into the environments where people actually are working with their data and have their hands on their data. So aligning again with the keynote yesterday, these three questions came up when evaluating different programming languages, but also these three questions I think come to mind when thinking about when to use interactive visualization. So these are important considerations in such that interactive visualization compared to other types of tools during analysis have a higher cost because they're hard to use. You typically have to download some piece of software or prepare your data or what sort of file format. And so the gain has to be great enough to sort of go over that overhead and actually try to use one of these visualization tools. And I find that my role sort of in this intersection between these two worlds is to try to make interactive visualization more accessible within computational environments. So I'm going to abuse this chemistry plot for those in the room that know this, but this is a reaction diagram showing potential energy of a chemical reaction. And on the left side, you have a high potential energy for your reagents, and then there's some activation energy that's required in order to carry on the reaction and carry out to the products which have a release of this potential energy. And so we call this upper limit here, or sort of the upper amount of the curve, is the energy that you put in to actually push forward this reaction to completion. And then this net release is sort of the energy that's released following this reaction. And I think there's a lot of similarities here in terms of thinking about our data and working with it and the insights that we can get out of our data. In that at the start of an analysis, we have all this potential energy of insight that we can get into that. But there's this overhead of either algorithms or toolkits that we use to try to release that information and gather that insight. And we can also think about chemistry. They use catalysts to try to lower this activation energy. And so what I want to convince you today is that widgets are really a catalyst to lowering the cost of using interactive visualization in computational notebooks. And that because they are in computational notebooks, there's actually even more potential to have more insight because you can deliver data and representations of those visualizations. So it's not just using the visualization, but you can actually pull out data from the visualization and use them in your analysis. So I want to provide a perspective on just the history of these two different worlds that I'll be talking about today. And I think it's fun to note that Python and the first website both came out in the same year. And there's been a lot of ground since that is of how these two massive ecosystems have evolved. And so we're all here because we love the Python data science ecosystem and what this affords. It's really the most effective and accessible platform, I think, for getting your hands on data and working with data. But in maybe the upside down world or a different world, you have the web world, which is not great for doing any of that data analysis, but really is designed around interactivity, visualization, and has this extensive amount of toolkits to make designing interactive applications accessible. So really you have this world of great accessibility of making applications and another that's really great with working with data. And traditionally, these were worlds that were quite far apart. But over the years, they've been getting closer and closer together. And in particular, when you're in a computational notebook environment, or many environments where you actually author code today are built, for better or for worse, with web technologies. And so Jupyter and its core architecture really has this front-end component, which is based off of web technologies and has this rich ecosystem for building user applications. And another part of Jupyter is its extensibility in its kernels. And by having these separated, there's been great diversity and innovation on both ends of this spectrum. So you have all these different tools which are Jupyter compatible on the front end, and then a large list of tools of kernels on the back end side, which really make Jupyter, I think, have really contributed to its overall success. And a Jupyter widget is a very important piece of this architecture that's different from this overall Jupyter's architecture in coordinating the front end and the kernel. And that's because a Jupyter widget spans a very small piece of front-end code and back-end code that third-party people can author and distribute. And that means that you can actually extend these computational environments with interactive tools based off of what's available in the web browser. So what I want to get into your heads today is that widgets really add a lot of oomph to what you can do inside of a notebook beyond just writing code and executing cells. So if we go over to a notebook, I have one here, in which I have this cars data set. And one way of visualizing this data would be to use a static plot. And what I want to get apart in contrast here is that we've already rendered this data by the time I'm displaying it here. So this is a pixel, this is a raster graphic, this is a PNG. And I can already see some points that I might want to pick out of this, but in using just my ability to type in code, it's actually kind of hard to pick out some of these points to actually define that query. And so we can use a little bit of interactivity in a notebook, but without widgets, initially using this Altair library. And so Altair, instead of rendering a PNG on the server, renders the data in the front end using a little bit of JavaScript. And I can actually select some points here and zoom in, and I also have the ability to hover a point. So if I wanted to know what this outlier was for sort of a point, I can at least hover over it. But one issue about not implementing this with a widget and just sort of embedding this HTML in the page is that the data is in that state of my selection is trapped in that output. So if I want to actually touch that point and get it back in any interesting way in my notebook, that's not possible. So you might expect as a Python developer, if I highlight these points, oh, maybe there's like a property to access that, and it doesn't exist. And so widgets are what close this loop, because they allow you to establish small pieces of data, or even large pieces of data, to share back and forth and communicate between the front end. So Altair actually now, so first I'll talk about what is a Jupyter widget. So SciPy widgets is a collection of all these Jupyter widgets that are essentially simple form inputs like sliders, buttons, which on the front end have a value such as an integer, which is shown here by this slider, but that value is also replicated on the back end. So when I move this slider, we can see that the value changes to the number 52. But then if I then look at that value in the kernel, the value is also 52. So there's this synchronization going on. And if I actually assign to this variable here, I can also update in the front end. So this is this two-way communication that anywidget and Jupyter widgets overall affords. And so what Altair has implemented now is a custom Jupyter widget on top of anywidget, which allows you to pull out that data. So whereas before, when I made this selection here, there was no way for me to bring out this data. With the Altair Jupyter widget, I can type in widget.selections. And now I actually have this bounding box that I've made in the plot above. And what's cool about that is I can consume that any way that I want in Python. So if I run this next cell, I can define a predicate for a pandas query, and now I actually have a data frame for the points that I've subsetted in this data set. So the point of this is just to show that you can define a small piece of functionality that really affords a lot of flexibility within the notebook. And the way I like to think about this is that you can make new Lego bricks with custom Jupyter widgets and anywidgets. But the other really cool part about Jupyter widgets is that people who don't need to know any JavaScript can figure out new and interesting ways to click those Lego bricks together. And so ways that you didn't even anticipate that people could use your custom widget can end up making interesting applications. So an example that I like to highlight from one of our community members, Vincent created this draw data widget on top of anywidget. And with the draw data widget, it does exactly what it sounds like it does. So if I zoom down here, I get a canvas, and I'll zoom out a little bit so you can at least see, where I can draw a data set. So it's just a matter of I can draw some points on the screen, and then in a cell below, I can actually access that data as a pandas data frame. And with the draw data widget, you also, what Vincent has set up in this notebook, which is when he announced this tutorial, is he has a machine learning model, a decision tree classifier that he trains on whatever the current selection is in the canvas widget. So if I add another class here, we can actually see what the decision boundary is. And this is just piecing together custom Jupyter widgets, and it didn't take writing any custom JavaScript code. It's just sort of building blocks and piecing these things together. OK, so widgets are awesome, but making widgets is surprisingly challenging. And the challenge with making widgets is that they tightly couple with many platforms. So I mentioned before that part of the amazing thing with Jupyter is that they work in so many different environments. And Jupyter widgets have the potential to work across all these different environments. But the way that you package your front-end code for these different environments is specific. And so that means that this JavaScript code that you write for your widget, it kind of has to fit these different puzzle pieces on these different platforms. And what that means is that each individual developer has to focus on trying to take this JavaScript code and transform it in a way that it can work across all these different platforms. And so the tools to do that are very much focused in the front-end ecosystem, which are very much unfamiliar for many Python folks. And then also when you actually want to package this up and share it, you have to both know the Python package registry as well as NPM. And so this alone is sort of absolutely not, I will never make a custom Jupyter widget. And I think it's this initial experience leads to very negative thoughts around the overall JavaScript ecosystem as a whole, which over the last 5 years has matured quite a bit. And this isn't just one widget. So this person did a great job. All these puzzle pieces are perfect. But there are plenty of other widgets that are out there that if you don't have all these different steps, now we have missing puzzle pieces, and suddenly widgets don't work across all these different platforms. And so I really got into this problem because I was maintaining a couple widgets for things in our group because I really thought that this would bring value to some of our collaborators. But over time, all of the issues that I got across those projects were just about platform compatibility and nothing related really to any of the features. So enter a specification. Anywidget is a specification that's built upon the browser's built-in module system that defines how you can declare and render custom widgets in the front end. And so this block here is no longer one of those puzzle pieces, and instead is a part of the ECMAScript standard, which is now supported across all browsers. So although all these platforms came out before the ECMAScript standard was introduced, because they all run in the browser, this module system exists. And we can leverage that to bypass all those systems. And so with anywidget, you declare your widgets using this browser standard syntax, and you export a set of functions that can be loaded and executed by the host platform. And then anywidget provides an adapter layer across all these platforms such that you don't actually have to write and transform your code. So instead, the code that you write is the code that you can share and publish with others. So right out of the box, there's no transformation step that's necessary. You can write your widget code and your Python code together in a single file and share that with someone, much like you would just a regular Python script. There's no need to install a custom Jupyter extension. It all just works. You can also prototype a widget directly within a Jupyter notebook, so you don't even have to open up a separate file. You can just start trying out something in the browser. And if you do really want to make something that is a package, there is a pathway to packaging that up and shipping it to PyPI that either you can choose to use many of the different tools that exist in the front-end ecosystem or no build and simply ship. So really the idea is to try to cover all these different use cases with Jupyter widgets and allow for you to get your hands on trying a little bit of JavaScript and see what's possible. OK. Enter your first AnyWidget. So we are going to the AnyWidget documentation. And within the docs, I can go to the Getting Started example. And I will copy and paste this example into this notebook. And right away, I have my first custom Jupyter widget. So in just copying and pasting from the docs, this is something that you could publish to PyPI, you could share with others. This just works. And to show you, I can make this counter. This is just a simple button that anytime I click the counter, it increments the count. And then in the notebook, I can look at whatever the counter.value is, and the two are synchronized with one another. And the important thing to note here is that all the APIs that are necessary to actually connect with the notebook are simply this model object, which is an interface for communicating with the Python kernel, and the element, which describes like the actual output on the page. And those are the APIs that you as an anywidget developer can expect on. And beyond that, that's it that you need to, we don't prescribe any other tooling. So because this is a regular Jupyter widget, we can make a custom SciPy widget of our own. So I'm going to import SciPy widgets. I can do SciPy-widgets.int slider. And what I'm going to make here is just a custom little slider like we had before, except I'm going to link that slider, SciPy-widgets.link, link that slider to the value property on both the counter and the slider itself. So now what we're going to do is we're going to have a mechanism by which we have a slider. Oops. SciPy widgets. Nope. There. And now when we move the slider, the two properties are synchronized with one another. And so one thing you might notice here is that this code is really this, like, we're writing this as inline strings, and like that can be a little bit hard to parse, especially if you're new to JavaScript. So with AnyWidget, you can actually move these source files to a separate file. So if I can get my, what is going on? There we go. If I can get this open here, I can copy and paste the render function into a separate file, and then I can change this to a file path. So this is going to be index.js. And then here, I can change this to my styles file and save. And then on the notebook side, I just need to change this path as well. So I'll just change this to styles.css. And as long as I've saved all these and I run, now everything's working the same. Except now when I increment this button or I move this slider, the widget state is being synchronized between the front end and the back end. And not sure what's going on here. The two are synchronized with one another, but because these are in separate files, any widget is keeping track of what changes are being made. So if I go to this background color here and I say I want to actually make this, let's see, light green, when I save that, you'll see that the widget updates automatically, and you don't actually have to rerun the cell or change any of the state. And the same thing happens for the JavaScript. So if I want to change, maybe we want to make this count have a bunch of exclamation points. Oops. If I save this, you'll see now the count has a bunch of exclamation points, and I can change the slider. So these are just sort of the development features that we've been adding in by unifying around this front-end standard. And you might be curious, like, OK, it's a button. Like, what else can you do here? And I want to emphasize that because this is a proper JavaScript module, we can actually bring in any dependency that we want that's publicly available. So I'm going to bring in a dependency that's called confetti from HTTPS. So this I'm going to grab from a URL, canvas confetti. And then within where we update the value in the count, we can actually just do confetti angle. And we're going to set the angle of the confetti to be whatever the current count is. So model.get value, and I'll increment it a little bit so we can see it. Canvas confetti. All right, I have an answer somewhere. Let's just grab this because it's working. So what I'll do is just copy and paste this in. I must have a syntax error, and I just don't want to. What's what? Not required. OK. There we go. OK, so we have this little counter. And now, because we're synchronized, we have a little cannon. And the point of this is just to show, like, off the shelf, you can grab a library and dump it into the browser. And really, you can incrementally just try to build up these things. But I was talking about all the capabilities of the web earlier and all the capabilities of Python just a moment ago. And a button with a confetti is not really like emphasizing the capabilities of either, I don't think. So this is just to give you an idea of what you can actually build. And what I want to preview now is something that I've been working on to that really, I think, is a good example of leveraging both of these environments. So the web, on the web side, like this is sort of meant to highlight like what you can actually do if you choose to embrace both of these platforms. So Quack is a data table library that I've been working on for any type of data that talks like a duck. And some of you might be familiar with the libraries that are involved if I say that, but the goal here is that we want to bring the web and SciPy ecosystems closer together. So on the web side, I'm using some of these state-of-the-art libraries like Mosaic and D3 to really leverage like the interactive ecosystem that exists there. And on the Python side, I'm using DuckDB and Apache Arrow and the Python data frame protocol to make sending data back and forth between these worlds easy. So I have my same data frame as before, but now with Quack, I can create my Quack widget, quack.widget. Oh my goodness, widget. And this is the Quack data table. So this, you can scroll, it's virtualized scrolling, so it doesn't load all the data at once. It does this virtualized, so you can view just as much of your data as you want. And it also implements cross-filtering across all columns. So as I highlight a column here, you'll see that I can look at subsets of my data, and under the hood, it's cross-filtering it. I can also do things like sort specific columns within my data table. The other thing I want to highlight here with Quack is that every expression that because we are using DuckDB and this Mosaic architecture, every piece of state that is being represented right now is expressed as a SQL query. So on my actual widget, I can grab the current SQL, widget, and we can see that this is the SQL that describes the table that I have above. And based off of the predicates that I have, you can see that these things that might have been hard for me to define using code, I can define in the UI and then materialize it on the Python side. So now if I call widget.data, it's going to run that query, and now I have that subset back in my data. And just to show, like that was a couple, like 100 entries. This is the New York Taxi data set, and this is quack.widget. And this is 3 million entries. And with this Mosaic architecture and DuckDB, we can actually cross-filter this type of data as well in real time. So the last thing I want to highlight is that the thing with anywidget is that it's a specification plus a toolkit for both Jupyter and beyond Jupyter. So the thing that I've been mostly talking about today is this front-end specification, which describes this common entry point for people to create reusable interactive widgets. And then the second piece I've been talking about is this glue code layer that adapts that to be run in all these computational notebook platforms. But beyond that, there are other frameworks and systems that are not Jupyter native that are looking to support this ECMAScript standard as well. And so what that means is that, like for instance, this Marimo notebook is not based off of Jupyter at all, but they've decided to build their third-party plugin system around anywidget. And so what that means is that you can use anywidgets in Marimo, and anywidgets made with anywidget work in more environments than Jupyter widgets. Okay, that was the most number of widgets. And then this weekend, I'm actually hoping to do a sprint with the MIST folks to try to add this sort of platform native support. So the whole point here is that you can incrementally learn these pieces. So you start with a little bit of JavaScript. You can then dive into our adapters to use React frameworks and Svelte and any of these things that you might have heard of. And then we also have a project CLI to help bootstrap like a widget project of yourself and help you get started. And with that, I just really want to thank everyone for coming today, acknowledge both my institutions and funding, specifically the High Dive Lab for supporting me to come here. And also, I really want to give a shout out to Nazar, who was here for the tutorial, but had to leave. And he's really been such a great mentor in trying to help me shape this project and push it forward. And then finally, I just really want to thank the anywidget community. So we have a Discord now. If you're interested, you should absolutely join. Like, there's a lot of cool things that are happening on our Discord. And the last thing I want to highlight is that we do have a community gallery now. So if you go to the documentation, you can sort of scroll through and see all the different cool things that people are building. Yeah, thank you so much.
Thank you, Trevor. Do we have any questions? No? Okay.
This is such an awesome piece of technology. Have you experimented hooking up the JavaScript event callbacks to Python routines? So for instance, having Python code in reaction of something that occurs in the widget.
Yes, so the data table library that I was showing uses that functionality of the library. So you can invoke functions on the Python side and respond when those functions complete. We're trying to add some more nicer APIs to do that, because right now you sort of have to wire up those callbacks together, and it'd be nice to have sort of convenient APIs to define those methods, but it is possible.
Any other questions? Well, I have a question of my own. So coming from the Matplotlib side, we used to be able to do Jupyter interactive stuff, and then that broke when SciPy widgets came along and the whole refactor and stuff. And so one of the things that we kind of want to have is that when you save your notebook and stop it, you get a static version of the figure or something that is there instead of just a broken like JavaScript thing. So how do you handle that sort of situation?
Yeah, so the way in the way in the notebook that you identify like how to display that particular component is using this like repr protocol that the IPython notebook has, and you can inject all the different reprs that are available. So one would be like a text representation or a PNG, and depending on the environment that's rendering it, it'll pick which version to use. So I would like to make that a little bit more formalized in anywidget, how to register the fallbacks in the case where you can't actually have JavaScript executing on the page, because I agree it's very important. So.
A sort of follow-up question to the last one. In the case of like visualizing multidimensional data, then you often find people building widgets to like slide back and forth along time or along space or whatever, and then they find some subset of the data that they want, and then they're like, okay, I'd like to sort of play that as a little movie and then save that out. Like, could the same approach you're just describing be expanded to like saving out sort of like video or GIF formats of like subsets of the parameter space of the widgets, for example? Does that make any sense?
Yeah, I'm not familiar. I don't remember all the protocols that the IPython supports. I can look into it, but what ends up happening, I guess the challenge there is that because notebooks are JSON, most of the time that you embed like a PNG, it's like base 64 encoded. So if it was a large video, you'd get like a pretty massive file, but it's sort of these considerations of is that worth it to just have some sort of a nice UI to look at later.
Right, interesting, thanks.
Any other questions? Okay, if not, I guess we'll thank Trevor once again. Nice.